Welcome to today's video. Today we're going to be focusing on determining the domain and range of functions and relations, and we're going to show that mastery by scoring at least an 80% on an exit ticket in class. Hopefully you have the note sheet in front of you. If you don't, take out a sheet of paper and we'll get you a fresh copy tomorrow. Now, when it comes to relations, the definition of a relation is just a set of ordered pairs. It can be a function, but it doesn't have to be a function. Now, when we talk about domain and range, the set of all x values is our domain, and the set of all y values is our range. And if you ever forget which way it goes, think of the alphabet. Domain comes before range in the alphabet, well, x comes before y in the alphabet. So it's just a little trick to help you remember. Now, if we look at our first example, we're given a set of ordered pairs. So first, I'm going to put them in the table. Well, my x is -3, 1, -2, 0, 1, 2, 3, -4, and -3, 5. Now, when I go to do my mapping, if we look, my top x and my bottom x are the same, so I only have to write it once, but -3, -2, 1, and 3. My y's are all different, so I'm going to put them in ascending order, 0, 1, 2, and 5. Now I'm going to draw my arrows. -3 goes to 1, -2 goes to 0, 1 goes to 2, 3 goes up to -4, and then -3 again goes back down to 5. And the last one we want to look at is graphing it. Well, if I graph -3, +1, I'm going to graph -2, 0. I'm going to graph 1, +2, 3, -4, and then I'm going to go back to -3 and go up to 5. Now, we have all our different ways to look at it. When we talk about the domain, it is all of our x values. So all from here, and in this case, it's going to be any of the lines that go straight down to the x-axis. Now, we don't want to repeat numbers. We don't need to say -3, -3. So in this case, our domain is just -3, -2, 1, and 3. And you always want them in ascending order from least to greatest. If I look at my graph, I can pull it by going, okay, my bottom point goes to 3. My next point goes to 1. I'm at -2 and I'm at -3. For my range, I want to look at my y values. So I'm going to look at the y table, the second part of the mapping, and in this case, I'm going to draw my lines over to my y-axis. And where it hits the y-axis is your range. Now again, we want to put them in ascending order. So it's going to be -4, 0, 1, 2, and 5. And if you notice, my table's not in ascending order. That's okay. Your table doesn't have to be. But when we write our domain and range, we want them to be. If we look at our second example, this time we're given a table. Well, we still want to be able to turn it into all the other sets. So first, from my table, I'm going to go to my mapping. I have -2, -1, 0, 2, 5. For my y values, I have -3, 4, -2. Oh, I have 4 again, so I don't have to write it. And -1. So now, if we match them up, -2 goes to -3, -1 goes to 4, 0 goes to -2, 2 goes up to 4, and 5 goes to -1. Now if I go to graph my points, I go -2 and -3. I have -1, -4, 0, -2, 2, 4, and 5, -1. Now, we also want to be able to write our set of ordered pairs. And think, x comes before y in the alphabet. We graph the x-axis before we graph the y-axis. So we're going to write our ordered pairs x, y. So my ordered pairs are going to be -2, -3, -1, 4, 0, -2, 2, 4, and 5, -1. Now that we have all our different types, let's talk about domain and range. Again, domain is just your x values, and it doesn't matter which one you pull it from. Just make sure It is all the x values, and they are in increasing order. Whoop, and the board's not going to work well. So, in this case, I have -2, -1, 0, 2, and 5. That is my domain. And I apologize that the board's kind of malfunctioning, but it is anything that is boxed in blue, or it is any of the lines drawn over. Ooh, and I drew my lines the wrong way. We want to draw them to the x-axis, not the y-axis. -2, -3, -1, 4, 0, -2, 2, 4, and 5, -1. So in this case, we want to actually draw them down to where they hit. Now, for our range, we're going to look at our y-axis. So it is anything that is there, or any of our lines, in this case, the lines I had originally drawn, over to the y's. Now, we do have a repeating y, so we don't have to worry about writing it again. So it's going to be -3, -2, -1, and 4. And again, it's in increasing order. Now, one thing we forgot to talk about with the first one, and you have a little bit of room off to the side. We want to talk, are these functions or are they not? Well, if I look, and I'm just going to add it here because I have some room. Again, we cannot have an x going to 2 of the same. You should not date your x's more than once. So if I look at my mapping, I have 2 arrows coming off of -3. This is not a function. If I look at my table, I have -3 listed twice in the x column. If I look on my graph, I have -3 hit twice when I do my vertical line test. If we look at the second one, if I look at my x values, whether I look at my mapping, there's not 2 arrows coming off any number. If I look at my table, there's no repeats. And if I look at my graph, it passes the vertical line test. So in this case, this is a function. Now, our last example. This time we're given a graph, and we need to recreate everything else. So start from the beginning and start with the ordered pairs. Pull your ordered pairs off the table. So if I look, my first point down here is going to be at -5, -4. My point in the middle here is at 0, -3. My bottom point is at 2, -5. Over here, we're at 4, 2. And here I have -2, 3. So now I'm going to write my ordered pairs first, and it doesn't matter the order. -5, -4, 0, -3, 2, -5, 4, 2, and last but not least, -2, 3. Now that we have our ordered pairs, it makes it a little easier to fill in the table and fill in the mapping. So from here, it becomes -5, 4, 0, -3, 2, -5, 4, 2, and -2, 3. Again, makes our life pretty easy when we go to the mapping. I'm going to put them in order this time. So now let's connect our arrows with our mapping. -5 goes to 4, 0 goes to -3, 2 goes to -5, 4 goes to +2, and -2 goes to +3. Now, if we look before we find our domain and range, again, is it a function? Well, if I look at my table, I have no repeating x's. If I look at my mapping, I have no 2 arrows coming off of one x. And if I look at my graph, there are not 2 points that hit the same vertical line. So yes, it is a function. For my domain, again, it's all my x values. So anything that hits the x-axis is in the x mapping or is in the x on the table. So in this case, we have -5, -2, 0, 2, and 4. for my range, I'm looking at all my y values. So anywhere they hit the y-axis in the y part of the table or the y on the mapping. So I have -5, -3, 2, 3, and 4. And you can pull domain and range from any of these different types. And that's why I specifically gave you one of each so that you can see the ways it is done. Now, if we flip over to the back, we want to talk about if we're given a continuous graph. For domain, again, domain is your x-axis. So we want to scan our pencil from left to right along that x-axis. For range, you want to scan your pencil from bottom to top along the y-axis. Now, because you can't see my pencil, I'm just going to create a different color line so that we can see what we're doing. Now, if I look at my domain in my first graph, I want to take my pencil and I want to scan it from left to right. If you notice when you scan it from left to right, it hits every spot on that y-axis. Everywhere my pencil is, there is a continuous point. So my domain is all real numbers. Now, for my range, if I take my pencil and I scan it from bottom to top, if you notice, it doesn't actually hit till I get to -2, but then it continues to hit every single point. So when we go to write our range, it is y, in this case, is greater than or equal to -2. My y values do not start until my pencil hits -2. And then it goes up from there, so it has to be greater than or equal to -2. If we look at the second example, again, for my domain, I'm going to take my pencil and I'm going to drag it from left to right. If you notice, it doesn't hit, well, now it hits at -3. It continuously hits, and then it stops again when I get to +3. So in this case, my domain, I'm starting at -3. That is my lowest value. So x has to be greater than that, which then has to be less than 3. And if you look, if we were to read this, -3 is less than x. Well, we want -3 to be less than x because that's my lowest value. But x is less than 3. So x is put between those two values. If we look at our range, it does not hit. Oh, it hits at -3. If we keep going up, it stops at +3. So our range is actually going to be the same thing. It's just now with a y value instead of x. If we look at both of these, my first graph, yes, it is a function because it does pass that vertical line test. However, my circle is not a function, but that just shows you don't have to have a function to find your domain and range. Now, if we look at example 3, I'm going to bring my pencils down. We're going to start with my domain, and I'm going to slide my pencil from left to right. If you notice, it hits every spot every time. So again, my domain is going to be all real numbers. In the case of my range, if I slide my pencil from top to bottom or bottom to top, if you notice, it doesn't hit up here, but my arrows say that it's going on and on forever. So it does hit all the numbers again. This means my graph is all real numbers for my range. It is a function as well. It is a continuous function. Now, please bring these notes to class. I know we're not going to finish all of them, but we're going to continue to talk about these in class when we see you tomorrow. I look forward to seeing you then.